Welcome back to class, everybody. Today's topic 3.2.3, how can I rewrite a product? So today I'll be able to multiply polynomial expressions and verify their distributive property using area models. So use the dimensions, length, and width of the area model to write the area as a product. The dimensions equal to the area is the sum of the parts. So first thing we're going to do, right, is do the first part. Let's write it as a product. So these two is what we call the factors. So in this case, let's put the top one, negative x plus y plus 2 right there. So negative x plus y plus 2, and then x minus 4 would be the second one. And then the multiplication of those two factors is our product. So what we're going to get is pretty much just the sum of all the interior parts. So let's multiply everything out. X times negative x gives us negative x squared. X times positive y gives us positive xy. X times positive 2 gives us positive 2x. Negative times a negative is a positive, and then 4 times x is 4x, and then negative 4 times y would give us negative 4y, right? And then lastly, negative 4 times positive 2 gives us negative 8. And then we want to see if we have any like terms in there, and if you guys notice, these are the only two like terms that we have. So here in this case, this would be negative x squared plus 6x, combining those two like terms, plus xy minus 4y minus 8. And that would be pretty much the product and the sum of the interior parts. All right, looking at problem 397, each expression below represents the area of a rectangle written as a product, length times width. So same thing, but instead they're just giving us the dimensions, right? They're not giving us the whole box pretty much. So sketch an area model for each expression on your paper and label its length and width. Then write an equation showing that the area written as a product is equal to the area written as the sum of the parts. All right, so again, let's draw our box. So remember, this one has two terms in there. So this would be a 2 by 2 box. 2 by 2. So again, doesn't matter where you guys really put x plus 3. You can put it here. You can put it on top. You can put it at the bottom. As long as the inside part makes sense, right? So on top, I'm going to put 2x plus 1. So, and then I'm going to multiply again all the interior parts. So 2x times x is 2x squared. X times 1 is positive x. 3 times 2x gives us positive 6x. And then positive 3 times positive 1 gives us positive 3. And again, in this case, I have two like terms. Remember the same base with the same exponent. Combine those, and we're going to start off with 2x squared. 6x plus x gives us 7x, and then plus 3. And then we're going to do the same thing for part B. So for this one again, draw your box. This would be a 1 by 2 box, right? Because we have two terms in here and then only one term outside. So 2x, and then that's our 1, and then our 2, x plus 5. So 2x times x gives us 2x squared. And then 2x times 5 gives us 10x. So this is going to be equal to 2x squared plus 10x. And we just rewrite it on top over here. All right, and then let's look at part B over here. So again, same thing we want to do here is do the same setup. So this is a 1 by 2. So this would be x, and then 2x minus y. Multiply it out, right? X times 2x gives us 2x squared. X times negative y is negative xy. So this would be equal to 2x squared minus xy. All right. And then our next part would be 2x plus 5 times x plus y plus 2. So this would be, again, has two terms, and this has 3. So this would be a 2 by 3 box. All right. So 2, that would be our 2. So 2x plus 5, and then our 3x plus y plus 2. And then again, we multiply everything out. So here we're going to get 2x times x gives us 2x squared. 2x times y is 2xy, positive. 2x times positive 2 gives us 4x, positive 4x. And then 5 times x is positive 5x. And then 5 times y is positive 5y. 5 times positive 2 gives us positive 10. And we're pretty much done. So we would just want to look again to see what like terms we can combine. In this case, we have the x's. So here we have 2x squared plus 9x plus 2xy plus 5y plus 10. All right. And then, for example, e, you guys just want to be careful when you ever see next. Remember, this means we're multiplying the same thing times itself, right? So 2x minus 1, so it's going to be 2x minus 1 times 2x minus 1, all right? Keep that in mind. Make sure you guys remember that. Whenever you see an exponent, it's just the same thing being multiplied by itself as many times as you guys see the exponent. So in this case, it's 2. So here we have 2x minus 1, and again, 2x minus 1. So we're going to be doing 2x times 2x gives us positive 4x squared. 2x times negative 1 gives us negative 2x. And then negative 1 times 2x gives us negative 2x again. And then negative 1 times negative 1 gives us positive 1. So we simplify this. We're going to get 4x squared minus 4x plus 1. And then the last part right there, we'll look at f. And this would be just, again, 2 times 4. So I'll give you guys 8. And then x times x would be just 8x squared. Again, if you do the box, you guys pretty much get the same thing, right? 8x squared. And then example G, we have 2 times 3x minus 5. So 2, 3x minus 5. Multiply, you're going to get 6x minus 10. So 6x minus 10. All right. And then on the last one right there, we have pretty much y times 2x plus y plus 3. So do your box. And then from there, y times 2x, that gives us 2xy. Y times y is y squared. And then y times 3 is 3y. So rewrite it. 2xy plus y squared plus 3y. And we're done.